Hi, my name is Margaret. In this video I'm going to introduce you to serialization and deserialization. I want to encourage you to program along, so try to get yourself the same setup. We have a package, serialization, and we have two classes. One is called demo serialization. In this class I'm going to show you how we can serialize both primitive types and reference types and how to recover the serialized information by deserializing it. And then we have a second class called demo serialization with custom types, where we're going to use custom types in combination with collections as we serialize and deserialize. Notice that I have a folder called binary files. That's where I'm going to store the files that we will create as we serialize our data here. Let's get started. Here I have my demo serialization. I'm going to start by creating a string array called words, and I'm going to include the 6 words 1, 2, 3, 4, 5, and 6. Now I'm going to print it. Let's run the code. So here we can see all our array elements. In order to serialize them, we need to know where are we going to serialize it to. We need a file, so I'm going to create that right here at the very beginning. It's a string, I call it file, and it is going to be right here in my source folder, serialization binary files. And I'm going to name my file words.ser. The extension ser indicates that this is a serialized file. At this point, I'm going to open up the Java documentation for the object output stream. Notice the object output stream is an auto-closable, so we are going to create it in a try with resource statement. I'm also having a look at the constructors. There are two options. One has no parameters, but this one is protected, so we don't have access. The second one requires an output stream. The object output stream serializes the objects that are on the heap, and then the output stream has to specify where is this serialized information going to. We want it to go to a file, so we are going to use a file output stream. Notice a file output stream is an output stream, and again it's an auto-closable, so we are going to declare it inside our try with resource statement. And I call my object output stream serializer. At this point I have some red wiggly lines. I'm going to import object output stream from Java IO, and now I need to provide the file output stream. Again, I'm going to import file output stream, and the file output stream needs to know where is the file. We have already a variable that stores the relative path, so we're going to provide that here. And the moment we do that, we get an even bigger red wiggly line. I roll over it, and I'm reminded that we have the possibility of a checked exception that needs to be taken care of. I don't want to add a throws declaration, so I'm choosing the second option here. I would like to have some catch clauses added. There are actually 2 of these. One problem that might arise is that the file is not found. So this could be the case if, for example, my path was misspelled. Alternatively, there could be other I/O problems. In this case, I'm going to add a message for the user. I'm going to do something simple like a problem occurred when serializing words. At this point, I am set up to do some serializing, and I'm going to start by serializing the number of items in my array. And because the number of items in my array is an integer, I'm going to say write int. So the number of items in my array is words.length. I have a typo here. Let's fix that. Now I'm going to use a loop to loop through all the elements, and one by one I'm going to serialize the individual strings. And this time each of the words is a string, not a number, so I'm going to say write, and you might notice there is no string, no write string, but there is write object. So I'm going to serialize them as objects. So at this point we have the object output stream that knows where to send the serialized information. We serialize the number of elements in a list and the words, and I would like to see the file that is created. Notice that we didn't include any print statements during the serialization process, only if an exception occurs. I would like to get some feedback when I'm done serializing. So right here at the end of my main method, I'm going to add a brief message that just says done, so I know that I arrived at the end of my main method. Now I'm ready to run my code. And you can see here it says done. When I look at my folder binary files, I don't see my words ser though. The reason is that the package explorer doesn't automatically refresh. So I'm going to right click, I'm going to say refresh, and now I can see there is my words.ser. I'm going to open it, and when I open it I can see 1, 2, 3, so it gives me evidence this is the information I try to store, and yet it doesn't start with my number 6, which was the first thing I did serialize, and it includes some strange characters. Binary serialized files like the one we just created are not intended for humans to be read, and especially they should not be modified by us. We are going to use the deserializer to retrieve the information that is stored in this file. I'm going to extract the method, and I'm going to call it serialize words. So here refactor, extract the method, serialize words. Let's just simulate that there is a modification of the data happening, and then we retrieve the original state. So here I'm going to loop through all the elements in words, and every second element is going to be set to null. Pause the video, give yourself a moment. When you're done, press continue. So here is something to compare it with. I'm going to run the code, and what we will see is the following. Half of them are set to null. If I want to have the original values back, I can get them by deserializing the file that we created before. So at this point I'm going to comment out my serialized words, because we don't want to serialize it over and over again. We did it already, it's right here. But I leave that line of code in my main method in case you would like to maybe change the original array, run it again. So it's right there if we want to use it again. Now also notice that we get a yellow wiggly line here, because now we have a method in our class that is never used. And I'm going to suppress the warning because the serialized words is only sometimes used. It's not intended to be used every single time I run my main method. At this point I have the word serialize, I modified my data, and now I'm going to create an object input stream in order to read back the data that is serialized in words.ser. Object input stream works very analogous to object output stream. You can look it up in the Java API. It's an auto-closable. It requires the information where is the file, where is the serialized data coming from. In our case, it comes from the file. So we're going to create an object input stream based on a file input stream. Here we go. Try with resource statement. Inside we have the object input stream. I call it deserializer. And I'm going to import object input stream. Now we're going to provide the new file input stream. Again, we're going to import file input stream. And now we have to tell the file input stream where the serialized file is, and we have that still stored in our variable file that includes the relative path and the file name. Similar to what happened before, we have the red wiggly line. We are going to include some catch clauses, and I'm going to accept the default exception handling where we just print the stack trace. And for the situation that a different IO exception is thrown, I'm going to add a brief message again. This time my message is going to say, a problem occurred when deserializing words. We are now set up to deserialize the information that has been stored in our file words.ser. The first thing that we serialized was a number. It was the size of the array. So the first thing we need to deserialize is the size of the array. I'm going to create a variable integer. I call it size, and I'm going to deserialize it. And we're going to say read integer because we stored it as an integer. And now we assign it to our variable size. At this point, I'm going to create a string array of the specified size, and I'm going to call it string array. And it is this big as specified in size. Now I'm going to use a loop to do something n times, where n is my size, and every time I'm going to deserialize the next string, and I'm going to assign it to the corresponding index in my array. So here is my loop, and every time we are going to assign something to our string array on that given index, and what we assign is coming from the file, and we're going to read it as an object because we stored it as an object. Now there's one issue. Here I have an array that expects a string because we declared it as a string array. The deserializer provides me with an object. Now I have to cast it to a string. This cast might or might not work. I remember I serialized a string as an object, so I'm confident it will be a string when it comes back. However, if I was wrong, or if somebody else was overriding the file with different serializations, then this would no longer be the case. So here I'm rolling over it. It gives me different choices. I could add a catch clause, or I could surround the smaller area with a try catch. So I'm just going to add it to my catch clauses. And so you can see here we have a third possibility. There could be the problem with my file path. There could be another IO exception, but it also could have a class not found exception. That is the case when my serialized object did not have a string serialized where I expect the string to be. And again, I'm going to add a note. I'm going to print that a problem occurred casting the deserialized object into a string. So at this point, the deserialized array is stored in my variable string array. And I would like to assign that new array to my original variable words. And when I try to do that, I get a red wiggly line because string array is declared inside my try block, so it gets out of scope right when my try block ends, I can put my declaration outside of my try block. I can bring that up right here, maybe assign it null at the beginning, and then inside my try block I'm going to assign the new array. This has to happen inside my try block because I don't know the size outside. I need to wait until I have deserialized the number that specifies the size of my array. So at this point my words has the original list of elements 1, 2, 3, 4, 5, 6, and we are going to print those. There's one more thing I would like to do at this point. We're going to extract another method, and here it is. I'm going to take the whole try catch statement and also the declaration of my array, string array. So here I right click, this is refactor, extract a method, and I'm going to call it deserialize words. Now here we are, you can see deserialized words, it creates my string array, and at the end it returns it so we can assign it to words. At this point we have those 2 lines of code. We can simplify that. Rather than having this string array variable in between, I can assign whatever deserialized words returns directly to my original variable, which makes my code more simple and easier to read. Our original words were 1, 2, 3, 4, 5, 6. Notice serialization was commented out this time. So we were modifying the original list. We were setting every other element to null and using words.ser, which we had created earlier, to retrieve the original values again. So I'm going to open up the code one more time so you can see all of the deserialize words method and also the main method. At this point we're done with demo serialization and we're ready to move on to demo serialization with custom types. Here we're going to create a list of a custom type, which is EquilateralTriangle. So we're going to start by creating this custom type. Here is my package serialization. I right click, I'm going to add a new class, and the new class is called EquilateralTriangle. And the triangle should be implemented as shown in this UML class diagram. You can see it has one field, the side. It has a parameterized constructor, a boilerplate getter, and a toString method. The toString method should return a string that looks like this. So if my side is 8, it would have a /8 \, which symbolizes the equilateral triangle. If my side would be 4, it would have /4/, whatever the side of the equilateral triangle is between the slash and the \. Give yourself a moment, implement the class. Please pause the video. When you're ready, press continue. Here is something to compare it with. I have class EquilateralTriangle, a private side. I added some doc comments, my constructor, and here is my toString method. I had to print my / twice because the / is the escape sequence in a string. At this point I'm ready to go back to my demo and I'm going to create a list of equilateral triangles and I'm going to fill it with 5 equilateral triangles with sizes 3, 5, 7, 9 and 11. Pause the video, give it a try. When you're ready, press continue. Here is something to compare it with. I was using the interface list on my left hand side, the class that implements the list on the right hand side. Programming to an interface is a good practice, so we want to do that. I was also using the method addAll from class collections, so I don't have to repeat the add statement multiple times. And here I was just adding 5 new equilateral triangles of the sizes 3, 5, 7, 9 and 11. And then I printed the result because I would like to see how that looks like and whether my toString method looks the way it should. And here I can validate that this is the case. In the first demo, we serialized the number of elements in each individual array element. That is one way to serialize, and I did it in order to demonstrate how we can serialize both value types and reference types, and also to demonstrate that we can serialize multiple elements at once. This time we're going to serialize the whole list just as one list object. In order to serialize, we need one more thing, and that is the file we're going to serialize to. So I'm going to create it right here. It's a string. Once again, I'm going to call it file, and it is a file that is located in my binary files folder, and it is called triangles.ser. Here we are. At this point, I would like you to create the object output stream that sets you up to serialize to this file triangles.ser. Please pause the video, give it a try, and when you're ready, press continue. Here is something to compare it with. Notice how I used a try with resource statement because both object output stream and file output stream are autoclosables. I also caught an exception. This time I caught only the IO exception, and last time we caught both the IO exception and the file not found exception. I want to have a brief look at the file not found exception. When you look at the inheritance, you can see file not found exception is an IO exception. This means I have a choice. If I make 2 separate catch blocks, I want to make sure that I have different exception handling. So in this case, we added a statement that we printed. Sometimes I might decide that it is fine to do the same exception handling for both situations, and in my case, I decided here just to show different ways of doing things that I'm going to print the stack trace regardless whether it is an IO exception or a file not found exception. At this point, I'm ready to serialize. I have my serializer and I have my list triangles. So I'm going to serialize my triangles. And I'm going to write them as an object because a list is an object. And so here we are serializing the whole list, namely triangles, as one object. At this point, the serialization is done, and I'm going to print a statement at the end just for my own feedback that the end of the main method is reached. So when I'm going to run my code, you might have noticed something red flickering by in the output. If I open it up wide, I can see that there has been an exception. It's a not serializable exception. And when I look at my own code, which is down here, and I wonder where did it happen, I can see it happens right when I try to serialize my triangles. Now the problem is the following. If I have a custom type, I need to open it up for serialization. We created the type EquilateralTriangle, but we never specified that it is okay to serialize it. I want to serialize it, So I need to allow for it to be serialized. The way we do that is by implementing the serializable interface. So here it says serializable, we are rolling over it. We are going to import it from Java IO. And the moment we do that, we get a yellow wiggly line, and this is a warning. So when I run over it, it tells me now that it is serializable, we should have a serial version ID. Eclipse offers to generate one for us. So we're going to click on that. A long number, the L indicates that this is of type long, and this is my serial version ID. It also comes with a doc comment because now we should provide some information about our version. We keep it short, we just call it version 1.0. At this point, I explicitly allowed for equilateral triangles to be serialized. This is necessary in Java. Unless a class gives permission to do so, the objects cannot be serialized. Now I go back and I'm going to run my code again. And this time I reach the end. When I look at my binary files folder, triangles.ser is not there yet. But we know already what we need to do. So we right click, we're going to refresh, and there it is. Now I'm going to open it up. And you can see that there are all kinds of characters that are not meant for humans to be read, but enough text to give us some feedback that yes, this is the file that we just created. You can see it's about equilateral triangles, it's about lists, but we don't see what those elements are. Again, files that have been serialized with the object output stream, which is a binary serialization, are not intended for humans to be read. I just want you to see how the files look like. At this point, we serialized it, and now we're going to deserialize it. I'm going to add a little comment here. And now we're going to deserialize. And the way we do that is by using an object input stream. Again, I would like you to set yourself up for deserialization. Please pause the video. When you're ready, press continue. Here is something to compare with. Notice, again, I used a try with resource statement. The reason is that both object input stream and file input stream are auto-closables. And I was again combining the IO exception and the file not found exception just by printing my stack trace. And now I have a deserializer. I'm ready to deserialize the list that we had created before. I'm going to add a list. That's the list where I'm going to store the deserialized list. So here it is, a list, and it is a list of equilateral triangles, and I call it triangle list. So I start by assigning it null, and in my try statement I'm going to use this list to assign it the list that I'm going to read back with the deserializer. So here's my deserializer, and we're going to read the object, and we are confident that this object is a list because we passed a list when we serialized it. Now read object returns an object, so I need to cast it to a list of equilateral triangles. This causes two issues: a red wiggly line, which is an error, and a yellow wiggly line, which is a warning. So let's do the red wiggly line first. What keeps us from compiling? And the moment I cast my object to a list of equilateral triangles, I might encounter a class not found exception. And that is a checked exception. It needs to be dealt with. This is not an IO exception. It has to do with casting, that I try to cast something that possibly is not a list of equilateral triangles. Here it gives me different options. I'm going to add the catch clause to the surrounding trie first, just to see how it is different. If I would do that, I would have two different catch clauses like we had before. If I want to have different exception handling, that is a great way to go. If I don't want to have different exception handling, if I want to do the same thing, let's say I want to print my stack trace, there is a better way. In that case, I want to add it to the existing catch clause. What this does to me is it says my exception is either an IO exception or a class not found exception. Very interesting syntax. Typically we have type name, and here it says this or that type. Notice the or pipeline here. One of those types is the exception. Whatever type it is, in either case, print the stack trace. So if two different exceptions or multiple different exceptions need the same exception handling, that is a beautiful way to specify that. The syntax error is now taken care of. We still have the warning. We have a problem with the unchecked cast from object to the list, and the suggestion is to add a suppress warning to the whole main method. Instead, I'm going to extract a method. After retrieving the list in my triangle list, I'm going to assign that to my original list, which had the name triangles. I just make this one extra step. And now I'm going to extract a method. I'm going to select my try catch and the statement that declares the triangle list. I'm going to right click, refactor, extract a method. I call my method deserialize triangles. And there we are. We're going to simplify again. So here is my triangles variable. And now we are having a second look at the warning here. When I roll over again, I can see that this time the suppress warnings is scoped to the deserialized triangles method, which I prefer because now it only applies to the deserialization part rather than the whole main method. We deserialize the triangles, we assign them to the variable triangles. Now we are going to print the list so we can see which elements are contained. I'm going to run the code, and I can see that my original triangles and my deserialized triangles are identical. Just to make the point stronger so we can see that the deserialization truly brought back the triangles that we serialized before, I'm going to modify them in between. And what I'm going to do is the following. I'm removing all the triangles that have a side that is 5 or smaller. Pause the video, give it a try. When you're ready, press continue. Here is something to compare it with. I use the method remove if. So if my triangle has a side that is less or equal than 5, it is going to be removed. And when we run the code, we can see that the original triangles list contained all the triangles. We removed the small ones, size 5 or smaller. But after deserializing, we brought back all the triangles that have been originally in the list and that were stored in triangles.ser.